we're going to do 16 through 20 on this round, okay? On this question here, it says a student slides 2 magnets onto a stick. Now I'm going to do an illustration here. A student slides 2 magnets on a stick. One magnet sits at the bottom, and the student holds the other at the top. Next, the student releases the magnet at the top and observes that it does not touch the other magnet. So, here's what I've done. I already have one magnet already on the stick. And then I'm going to take this other magnet and I'm going to place it on here. Notice what happened, okay? Notice it is not attracting and falling straight down. And I'm going to push on it for a minute and see what happens. It jumps back up. Goes back down. It jumps back up, okay? So notice that there's a space once I put it on the stick, on that question, on that observation. And that's pretty much what's happening here. Which explanation describes the forces acting on top of the magnet after it is released? Well, guys, anytime you put the magnet on top, gravitational force is going to be pushing down. It's going to push. It's like when you jump up in the air, gravity is going to pull you back down. From the last video, remember, gravitation is going to pull you down towards the earth. So, this magnet is not, by gravitational force, shooting up. It's coming down by gravitational pull. Okay, so it's got to come down. But notice that the magnet here, it's not going all the way down. So that means that the magnets, remember we talked about magnets earlier this year, okay? If you have 2 magnets, which I don't have them right here with me, okay? Opposites attract each other, so if you have a north and a south pole, they're going to want to come close to each other. If they are opposites, they want to attract, okay? If they are the same poles, so let's say we have a north and a north, they repel each other. They don't like each other, and they're going to go the opposite direction, okay? So, which explanation describes the forces acting on top of the magnet after it's released? Is it A, the gravitational and the magnetic forces both repel the magnet? Well, guys, the gravitational force has to go down. B, the gravitational and the magnetic force both attract the magnet. Well, is there an attraction going on here? Okay. C, a gravitational force repels the magnet, but magnetic force attracts the magnet. Okay, is there attraction? Or would it be D in this one here? A gravitational force attracts the magnet, but the magnetic force repels the magnet. Okay, so gravitational force is attracting it. D is going to be your answer. Because gravitational force is attracting it, because once I put it on, it's going down. That's the attraction because it's going down. But the magnetic force is repelling. That means we have opposites that are going to attract. That means that we have same poles. Now I'm going to show it. I'm going to flip it around. Because remember, opposites attract. That meant these 2 poles were and then if I flip it around, notice the repellent. Okay?
Ms. House, what if gravity repels it? What would the magnet do if the gravity? Okay, all right.
Shoot up off.
So gravity is definitely not repelling.
Correct. Remember, gravity is going to pull you down. If not, it's going to be shooting back up. As I tell the kids here in class, Mr. Newton out here, when he got hit in the head with the apple, he was like, "Hey, what's going on? Why did this apple not shoot off into the air? Why did it come down?" And that's where he started studying. Why did this? It was a gravitational pull too. Okay? All right, let's go to number 17. In question 17, it says in 2014, the Hayabusa, I'm going to say this what we're going to say called, 2 space probe was launched by the Japanese Space Agency to collect and return rock samples from Ryugu, an asteroid in the solar system. Hayabusa 2 reached the asteroid in 2018 and used a specialty designed impactor device to blast the surface of Ryugu in order to collect rocks from beneath the asteroid's surface. It left the asteroid in 2019 to return to Earth by the end of 2020. How did this Hayabusa 2 space probe unique from other space probes? Well, we know that this probe went, okay, and as it got on there, it blasted the surface of Ryugu in order to collect rocks. So we know it went, blasted, collected rocks from it, and then it brought it back to Earth. Okay, so that's what's happened if you read the little snippet there. So how is this probe unique? A, it's the first successful flight of an unmanned space probe. No, that's not really what we're talking here. B, it's the only space probe to travel beyond Earth's orbit. That would mention it here. C, the space probe can communicate and receive signals. Was that mentioned up here? No. The space probe was used an impactor. Notice that you can match the word impactor here and impactor device to collect different types of rock samples. So our best answer for number 17 is D. Let's go to 18. All right, I gotta sneeze, so give me a second. I almost sneezed which one.
Okay. Bless you.
Okay.
Bless you.
And then maybe a third will be the charm. All right. We're going to use this information that we have for questions 18 and 19. So this is a two-part. A librarian uses a cart to return books to the shelves. The librarian pushes the cart across the floor. So they're pushing the cart across the floor and lifts a book from the cart and places it on a high shelf. Okay? So we know we're going, pushing, and we're putting the book up. It says which pair of vectors, and guys, vectors are directions. Vectors are directions. Vectors are directions. It may be this north, south, east, west, up, down, right, left. Vectors are directions. So you have to have a direction with your answer because it's asking for which pair of vectors can be used to describe this book's motion. So if we look at it, A is 1 meter and 0.5 meters. That can give me a direction. B, 10 north and 0.5 meters per second. Well, I have a direction here, but I don't have a direction there.
That's Newton's. That's not a direction south.
Newton, my fault. 10 newtons forward. C, 10 newton forward and 0.5 meters. This one doesn't have a vector at the end of it. Okay. Here we have D, 2 meters per second right and 0.5 meters per second up. Notice there's two vectors here. Right, because we're going with the cart going to the right. 0.5 is what's him putting the book up on the top shelf. So D is our better answer here because your vector right, vector up. Okay, you have to have two vectors to have your answer. 18 is D. All right. Number 19. It's a little complicated, okay? So I'm going to kind of explain it the best that I can on this one. Now we're going back up to where it says about the librarian and the cart. It said which graph shows how the reaction of the force of the librarian's which graph shows how the reaction force from the librarian's action force of pushing the cart changes as the cart has fewer and fewer books. So we're having to push this, we have this librarian, he is pushing this cart, okay? And as he's pushing this cart, he's taking the books and he's lifting them up. So think about, the cart is getting lighter as they are pushing it up. And I had to draw some figures, okay, to help you kind of explain how this is going to go. So, we're going to say that we have the librarian, and then he's going to be a positive, okay? And the cart is going to be a negative.
Because it's the opposite direction.
Because it is the opposite direction. And remember, you're going opposites this direction, so you're going to have a positive one way and a negative the other. If they were both going the same direction, they'd be positive, okay? So, but they're not. They're going opposite directions. So that's where we have a positive and a negative, okay? Then, here's our chart. I'm going to go ahead and give you the correct answer in this one to kind of help you out.
It's right there. Yeah.
And if you look at this chart here, notice if you're going the opposite direction, you can eliminate two answers real quick. Notice these are going the same direction. Notice these are going the same direction. So we know these two are going to be already out of the picture, A and B. Now, if we look at this one here, we're down to C and D. Okay? Now, the thing of it is that when you start taking stuff off a cart, do you start gaining more force? Or do you have less force? Where do you go to? What is your number you're aiming for? It's going to be 0. You're going to look to go to 0. In this one here, notice that this guy right here, the car, he's going up with more force. So why would you be gaining more force? Okay? Notice here, we're going to 0. Okay? Notice it's going to the 0 in this one. D is going to be your answer in this one. But you want to go to 0 because you're going to have no force in this. So when you look at this, the card is going opposite from the librarian. And as they're pushing against each other, eventually, as you start pulling these books off, you're eventually not going to have any force that you really need. It's going to go to 0. So this negative 10 with the cart is going to 0, and this positive 10 from the librarian is going to 0. So they're going to meet at 0, not needing a force to it. Okay? So D is your best answer. Last one, number 20. In question 20, it says we have a 10 kilogram object is at rest on the ground. And of course, I'm gonna have to show you how to do this and how the easy way to do this with all of these. Okay. I'll try to put it in.
Yeah, you're good.
Okay, so we have this box, and if we have this box of 10 kilograms, and we have a right and a left, so we know that they're going opposite directions. If they're going opposite directions, you subtract. If they're going the same direction, you're going to add. So think of it like this: same direction, you're going to add. If they're opposite, you're going to subtract. We did that the very first 2 weeks of school. We had a worksheet on that. Okay. All right, so we're going to figure out which values for x and y will cause the object to move to the left the greatest speed. So we need it to go to the left at the greatest speed. So we're looking for the biggest number here, going to the left, okay? So what we need to do is plug in these numbers. So if x is 20 and y is 30, and we subtract 20 and 30, notice that this one is going to be the greatest. Well, we're looking for the greatest to be going to the left. So we know automatically that's going to be a wrong answer. Okay? Let's go to B. Our x is 20. Our y is 10. Well, when you subtract them out and you see the difference in the subtraction, notice this one's going to have a plus 10. Well, this is going to be your right answer right here. So B will be your answer. Because even if you plug in 10 and 10, it's going to equal 0. If you put 10 and 5, you're not going to have either.
Well, you'll have 5.
You'll have 5. But
And
you want the greatest, the biggest number, and I'm glad Colin said that. You're looking for the biggest. Even though this one is going to have a plus 5 to it, which one of these two has the greatest positive to it? Okay?
Moving to the left.